Hello everyone, welcome back to OTK Academy. Today we'll be looking at a differentiation question from the AQA A-level maths paper from 2018. So this actual question's worth 7 marks. I mean, that's a lot of marks to grab. And we'll look at how to actually attempt this. First of all, if you read the question out, find the coordinates of the stationary point of the curve with the equation x plus y minus 2 squared equals e to the y minus 1. Now, the first thing I would sort of catch is the fact that they mentioned a stationary point. We know that when it comes to a stationary point, it's when a gradient or when the gradient is equal to 0. So when dy over dx is equal to 0. So before I do anything, I would actually write that down. So I would say at a stationary point, dy over dx is equal to 0, right? That's the first step that I would take. Next, when we actually look at the equation, we can see y terms as well as x, so that should remind us of implicit differentiation. Looking at sort of this whole function on the left hand side, this whole all the terms on the left hand side, we should sort of be thinking of the chain rule method in differentiation, and those are the sort of two things that you should be aware of. So let's start by differentiating the left hand side first. Okay, I'll color code it to blue. So when we differentiate using chain rule, we know that in chain rule we take the power and bring in front of the bracket, so that's 2, and then we literally write the bracket how it is, x plus y minus 2. We subtract the power by 1, and hence it's just 1. We don't have to write that down, and then we multiply the whole thing by differentiating what's inside the bracket. So when you differentiate x, it's just 1. When you differentiate y, here's the implicit differentiation. So when we differentiate y, we get plus dy over dx, and differentiating a constant is just 0. Equals to, now when we look at the right hand side, it's far easier to actually differentiate because you don't have much sort of terms there. It's just e to the y exponential, so differentiating e to the y will just give us e to the y. Sorry, let me just make that less thick. Okay, that should do it. Yep. Okay, so that should give us e to the y dy over dx. So just to clarify it, this is what we're doing. And then again, minus 1, differentiating a constant gives us 0. So now things are far more simpler. You'll realize that if we write this initial statement, because it makes things for us in exam more clear as well. Looking at this, dy over dx is equal to 0. If we sub in this 0 for every notation of dy over dx, so let's do that. So we would have 2x plus y minus 2 multiplied by 1 plus 0. You don't have to write that down, but I'm just doing it to make it more clear. Times by e to the y times by 0. Now, there's certain things that are very clear here. Every time you multiply by 0, you always get 0. 1 plus 0 is just 1. So it simplifies things a lot now. So if you actually write that down again, we get 2x plus 2y minus 4 is equal to 0. Now to further simplify it, we can just divide everything by 2, which would give us x plus y minus 2 equal to 0. Right, and now we can either rearrange for y or x. I'm just going to do it with x. So x equals, bring y to the other side, minus y plus 2. Right, now this should ring a bell. This sort of mirrors the format of a simultaneous equation where you have this sort of rearranged equation, which you can substitute back into the original equation here. And you'll notice something, that when we substitute this back, we have terms cancelling out totally on the left hand side. So if I were just to write the actual equation down just to make it more clear, so we had x plus y minus 2 squared equaling to e to the y minus 1, right? And now if we sub in this for the x, we would get minus y plus 2 plus y minus 2 squared equal to e to the y minus 1. So everything cancels out really nicely, right? So you end up with 0 equals e to the y minus 1, which is the same as e to the y plus 1, now using logs to cancel out the e. Y equals, sorry, missed out what equal sign. So y equals ln 1. ln 1 is equal to 0, right? So we know our y term now. Simultaneous equations again. Substitute the value of y back in. We get x equals 2. So those are our two coordinates of the stationary point.